Good day, students. You are welcome to session 3 of Unit 6. In this session, we are going to look at standardization of sodium thiosulfate using potassium permanganate. Now our objective. By the end of this session, you should be able to standardize sodium thiosulfate using potassium permanganate. Okay, so let's look at this problem. A is 0.02 mole per dm cube potassium permanganate. B is a solution of sodium thiosulfate of unknown concentration. And C is potassium iodide solution. Okay, now from what we see here, it is obvious that we will start working from the A because we know its amount concentration here, and definitely we will know its volume as well. But as to move from when we are done with A, as to whether we will be going to C or B, the instructions below would indicate what to do. We have to put B into the burette and perform the following exercises. Measure about 20 cubic centimeters of solution C into a conical flask and acidify with about 15 cubic centimeters of dilute sulfuric acid. Pipette 25 cubic centimeters of solution A and add it to the acidified solution in C. What it means is that from A we'll be going to C because we are going to put A and C together. So first we expect a reaction between A, the permanganate, and then the iodide. We expect such reaction. Okay, so let's continue. And titrate with B using starch solution as indicator. Yes, and so finally, after C, we'll be going to B. So that is the direction. A, C, B. Alright. Write ionic equations for the reactions taking place, and then from your results calculate the concentration of B. B is the last solution, and so before we get there we'll do a lot of calculations before. Alright, so concentration in mole per dm cubed and grams per dm cubed. We have these atomic masses. Definitely we will need molar mass. Take the average volume of B used to be 24.7. For the A and C, we have been given their volumes. Alright, solution. So we have to write equations to show the reactions taking place. Like we said, we are expecting two reactions. One is when we add the iodide to the permanganate, that is A and C. When we put them together, we expect this reaction. And so this is what we are going to have in the solution. It's a redox reaction. Okay, we have removed spectator ions. So in this solution, when we do the titration, then we expect the thiosulfate to react with one of them. Which one is that? It's going to react with this iodine over here produced as product. So this is a redox reaction where this iodide is oxidized. So the oxidation number has increased from negative to positive over here. There is 0 here, and before you move from negative, any negative number, to positive, it means you have increased. Alright, so this iodine produced would react with the thiosulfate, and so we expect this reaction over here. So in the course of the titration, this is what would happen. We'll have the iodine from the first reaction reacting with the thiosulfate ions to produce the tetrathionate ion and the iodide. So here we have the iodine reduced and the thiosulfate oxidized. It's also a redox reaction. We have said enough about the equations. Let's move on. So looking at this clearly, before we can proceed, we need a relation between the permanganate, since that is what we have concentration for, and this iodine here. We need to relate this here and the iodine, because it is through the iodine that we can get to the thiosulfate. So the direction is like this. We move from here to here, and then from here to here. Alright, so from the concentration of the permanganate, we are still using the first principle. So we are not quoting from this here. We just need to interpret the concentration and move on. We're given 0.02 moles per cubic decimeters. And what it means is that 1000 cubic centimeters of the permanganate contains the 0.02 moles. Now we measured, or in the question, 25 cubic centimeters of the solution was measured. So if the whole of the 1000 contains the 0.02, then 25 will contain what? When we work this out, we have 0.0005 moles. Now remember, here we are only passing through, so we have this, and we need to find the corresponding moles of the iodine here. And so we go back to our equation to look for the mole ratio. From this equation, 2 moles of the permanganate ions produce 5 moles of the iodine. Here is at the product side, it's not at the reactant side, so it will not react with this iodine, it would rather produce it. Okay, so if 2 is equal to 5, then 0.005 is equal to what? If we put x there, then we are going to have x to be equal to 5 times 0.0005 divided by 2, and that gives us the moles of the iodine. That is 0.00125 moles. Okay, now remember that we are only passing through the iodine to get to the thiosulfate. We don't actually need the concentration here, and this is the number of moles that reacted with the thiosulfate. This is the number of moles of the iodine produced, and it's the same number of moles that reacted. And so right from here, we look at the reaction between the iodine and the thiosulfate. Here, from this reaction equation, 1 mole of the iodine would produce 2 moles of the thiosulfate ion. So if 1 is equal to 2, then 0.00125 is equal to what? So when we work this out, we are going to get 0.0025. Now this is the number of moles of the thiosulfate ion. If we know this, then we should note that this is the number of moles in the measured volume, or in the volume of the B used. That is the burette content. So this will be the number of moles contained in the 24.7. But we are to find the number of moles in 1000 cm cubed. So if 24.7 contains 0.0025, then 1000 will contain what? If we say 1000 is equal to x, we can make x the subject. We are going to get x to be equal to 1000 times 0.0025 divided by 24.7. And that gives us 0.1 moles per dm cubed of the thiosulfate ion. Okay, so this is the concentration in mole per dm cubed. The next is to find the concentration in grams per dm cubed. And with that, we are going to need the molar mass. So molar mass of the sodium thiosulfate, we work it out from the relative atomic masses, and we have 158 grams per mole over here. We know that there is a relation between, or there is a relation among rho, that is mass concentration, amount concentration, and molar mass. The relation is such that rho, or mass concentration, is equal to amount concentration times molar mass. We have values for all these terms, so we just put the values there. C, concentration, we have found to be 0.1, and then the molar mass is what we have calculated here. When we put them in, we have 15.8 grams per cubic decimeters. We are ending the session with a self-assessment question, still on redox titration. Please try it once you have the volume, or you've been given the volumes. So try solving it. And I hope you enjoyed this session. We'll meet again in the next session.